started. It's already 15:15, so anybody that woke up late, they could have joined us by now. Okay, and oh, I don't know what that pinging is, but we have a pinging. I don't know why. Okay, right. So I wanted you to explain the stages in the gas chromatography. Gas chromatography connected to the mass spec. So there you put your mixture in. Your mixture gets separated out. You get a graph that tells you the retention times. Okay, how long it took to get from the inlet to the detector. Okay, that gives you retention time, and the area under the curve gives you the percentage of that component out of the sample that you gave. Okay, and all of that is automated usually. Now, by now it's been automated, right? And then as your components come out, they're put into a mass spectrometer. You should have notes somewhere at home about how mass spectrometer works. So mass spectrometer goes in, and we did that whole thing where you had to draw, and it's put in a magnetic field. The sample is bombarded with ions. One electron comes off. Sometimes the electron comes off from a bond, so the bond is broken. The molecule splits up, and you end up with this thing with peaks. Okay, and then the first thing that will tell you not only how the molecule has split, but the molar mass. And the molar mass is a really good indication of how many how big the molecule is, what atoms it may have in it, depending on the size. Okay, so if we have a look, the next question asks us to explain how gas chromatography separates the components in the mixture. Okay, so how does gas chromatography separate the components of a mixture? Right, so it uses certain features. So I'm not going to write a paragraph. You can write the paragraph in your own features. So the gas chromatography uses certain features. So I'm going to put, so anybody got any features? You can put your mic on, or you can type any features that it uses. What does it use to separate a component? So we want kind of keywords. Let me type. You can put your keywords. Oh, good, lovely. I've got it locked onto capitals and I don't know what's going on. There we go. So you can actually type in the shared notes, people, if you want to. Oh, I've got more messages below. Let's have a look. Okay, stationary mobile phase. Excellent. Well done, Lawrence. You can put that in there. Right, yeah, stationary mobile phase. Okay, and in the gas chromatography, what is the stationary phase? Oh, sorry, not Lawrence. Who is that? Oh, it was me. Oh, it was not me. Okay. Oh, I don't know who it was. Oh, well done, whoever it was. Oh, didn't mean to do that. Okay, stationary mobile phase. So what else? Does anybody can type on this? Anybody want to put tell me if so what is the stationary phase in gas chromatography? Nobody remembers. Oh, I don't know who that is. Yes, definitely the thin layer of liquid. And this thin layer of liquid is supported by column. I'm going to spell column wrong, probably. Supported by the column, which is solid. Okay, excellent. And the mobile phase is the unreactive gas called a carrier gas. So excellent. Something a bit like, say, argon. Okay, and then I don't know whoever wants to type it can put any more clues that we might have. So the mobile phase carries the lighter components of the sample. Yeah. So mobile phase carries lighter components sample through oh, that's a very nice through spelling column. The column faster than your components. Often the the traction or absorption of the components. The mixture makes a big difference. Mixture makes contributes, should I put? Yeah, that's more formal. Contributes to the speed with which the component travels. So essentially what that means is the mobile phase carries lighter components of sample through the column faster than the heavier components. Often the attraction or absorption, if I can say it properly, of the components of the mixture contributes to the speed to which the component travels. And detector detects time of arrival of molecules and number of molecules arriving at given time. Okay, I think that's enough. Right, so the detector will detect when the molecules arrive and all of the particular component and the number of molecules arriving, or the amount, should I say. Maybe number of molecules, it doesn't give you a molar, so maybe I should put amount in there. Amount would be a better. Arriving at a given time. Okay, so you end up with something like there is in question 2. So you end up with this where you've got time at the bottom. Let me see if I can enlarge it a little so I can see it more clearly as well. Okay, and there you are. You have time across the bottom and intensity of response across the side, not identity, because the retention time gives you the identity. So there are two components in this mixture. Okay, and let me put Q1. There we are, there's Q1. And then I can put, where is it gone? And Q2, and that would be A. There are two components in that mixture. And then estimate the area under each peak. Assume each peak is a triangle and hence estimate the percentage composition of the mixture. So only those of you with a pencil, a ruler and the actual booklet will be able to do this part. And actually I left my booklet locked in my lab, so I don't actually have a hard copy of it. So I'm going to leave this to all of you to do, and let's see if we can agree. So what you have to do is we're going to use this formula, which is a half base times, and you've all used that before. So what you want to measure is this area here. Now I'm going to try and use my wiggly pen to do this. Oops. Okay. Right, and I want to use a pen, and so you take a ruler and you just put a line down there. If I can get it to line. Can I? Yep. From there to there. Okay, and you measure that, and that is your base. So this measurement across there, I know it looks, this is terrible. Clear it all again. Right. So I can enlarge it first. I've zoomed it in a little bit. Right. So you measure from here to here. The base, still really bad. And then you measure the height. And that is your height measurement. That is your base measurement. It should be from where this starts. So for both of those, we can measure the components of the mixture then. So you for A, so for A equals a half base times height. So it should equal, okay, half. Oops. Problems writing a 2 there. So can anybody in the public chat, can you tell me how wide the base is in millimeters? Oh, sorry. Won't let you scroll down. Oh, not sure what that means, Yasser. What won't let you scroll down? Okay, anybody got the pencil and ruler and calculator with them? If you've got your phone, you can use your calculator on your phone, but you might need a ruler. So somebody's going to have to tell us, because I haven't got a hard copy. Nope, nobody got a hard copy. Oh, Safi's typing. Nobody has a ruler. Appears, or the height is 20 millimeters. Because I'm pretty sure from there to there is not 20 millimeters. Yeah. So Piers did the height and Nilesh has done the base. So if we put that into our equation, so a half times 5 times 20 should give us, I like the base. Okay. Right, so if I do that on my calculator, somebody else has not done it already. So half of 5 is 2.5, 2.5 times 20, so it gives us 50 millimeters squared. So that gives us 50 millimeters squared. Okay, and then for B, if you do the same for B, we're doing a half base times height, so it'd be a half. And the base in B looks smaller. So anybody done the base for B? What is that, Lawrence? 38. Excuse me. So I'm lost, Lawrence. The height for A. Oh, okay. So it's not 20. No, it is. Let me correct it then. Ah, okay. So if I change that to, how much am I changing it to? 38. That's only because it's easier to correct, Ninish. Okay, so that's 38. So let me do that one again. So let's correct that. Okay. So let's see, 38. 2.5 times 38. 2.5 times 38. Oh, I've done it wrong. Right, okay. 2.5 times 38 equals 95. Okay. 95. That would be for A. And then for B, we've got base 3 times a height of 25. Okay, and what would that tell us? So 1.5 times 25 was 37.5. Okay, so I'm going to type that into our shared notes. Okay, right, so for A, a half base times height equals half of 5, half of 5 times 8. Okay, if you measured it as 37, that's fine. Normally, if you were doing an exam anyway, they have a little bit of leeway for your measuring. So equals 95. Okay, and then okay, and then we'd have for B. Oh, thank you. Oh, I'm liking this. Someone's a lot faster than me. I like you. Right, there we are. Okay, and so hence the area under each peak, assume each peak is a triangle. So I'm going to get rid of this, all of those notes, because we've now got them on there. Thank you, person who types faster than me. And then let's reduce the size. Right, estimate the area under each peak and estimate the percentage composition of the mixture. So to do the percentage composition, which we do at the bottom, percentage composition, right, we add both of those together. So not, if somebody else wants to type this faster than me, that would be nice. 95 plus 7.5. You add them together, and that's your total. So that would be 95 plus 37.5, not 3,700, right, 95 plus 30 is 132.5. Okay. And that is our total. Oops, come down again. Let's go back. Okay, and then so then to work out the percentage composition of each. So for A, our answer is going to be 95 over 132.5 times 100. And that should give us our percentage composition. 95 divided by 132.5 equals, so that'll be 71.7. 71.7%. Okay, and then we could do the same for B. Right, so I'm showing you this and I'm writing it down because the next thing I'm going to do is give you one to do on your own. So you do need a ruler for this next section. So in millimeters, we're measuring, in millimeters, we're going to be measuring. So the next, obviously for B, the composition is going to be lower. So it's 37.5 divided by 132.5. Sorry about my terrible slow writing. Times 100. And that should give me the rest of it, which would be 29.3, I'm assuming. Okay, and I'll just double check that. Okay, so that would be 37.5 divided by 132.5. Yep, 28.3. Okay, so that would be our percentage composition. So if we had 1 gram, 71.1% of that 1 gram, or 0.717 grams will be made of A, and the rest of it would be made of B. So if it's just got 2 components. Sorry, oh, here. I've got some more comments. Where are we? Oh, sorry, Justin. Yeah, the same with you, Justin. That's the same with me. I don't have one. Okay. Ooh, what's going on? Okay, let me fix that. Right, there we are. Right, so if I look at the shared notes. Okay. There we are. Right. Okay. Right. So we can turn over to the next page. Is everybody ready for that? Could you just let me know? Because I'm wondering if I'm going too fast or going too slowly. Okay, there we are. Okay. Right, so we're doing a percentage composition. So we need to do. Oh, lovely. Look at my chromatogram. I hope it looks better in yours. Right. What's happened to that? Right, so I'm going to open in my other screen. So I've got another screen. I'm going to open. I can't believe it. Right. I'm going to open an actual copy that's not dark for some reason. Right, let me open that. It's quite... Okay, so right, okay, right, back to the chat. Where am I? There we go. Right, so can you all see it properly? Because I can't see it. I don't know why it's this hideous combination. I have no idea why. But if you look on your hard copy, and in my, when I open it normally, it opens with Word and I can see it. Okay, so Josh can't see it. You can't see it on here, but can you see it on your own copy or on the electronic copy I sent you? So you could open that too. Okay. Josh, can you try it? Because I emailed you hard copy too, because I cannot see that. Why is this hideous color? Okay, so what I'd like you to do is have a go at the questions. I'm going to leave you 10 minutes. I'm putting my timer on. I'm going to go off and warm my tea. And if you need to go to the loo or anything, or splash your face to wake you up, whatever, this is the time to do it. But have a go at each of these questions. Ooh. Right, let me check my email, Josh. Right. Oh, thanks, Alfie. Right, okay, so right. Oh, right, let me go back. Oops. You can still hear me, and I'm web conferencing, and I don't know what I'm doing. Hold on. Josh, it's the one you've just sent to me. Should I send it back on the same one? You've sent me a copy of the work, so it should be on the next page, shouldn't it? Okay, right. Let me do that now, or I disappear. Okay, and send it back to you. Oops. So Josh, I've just sent it to you on the email that you emailed me with. Okay, it says it's from your. You sent me a PDF from your phone, and I sent it back on that email. Okay. Right. Is everybody okay with that? If you just put a yes in the public chat.
Snow, did you get my other email? I've tried sending it to the Snowman one.
Okay, let me just see. I've got one from Alfie this morning, Josh. Yes, I think I have. There you are.
There we go. Okay.
Yeah,
thank you.
Perfect. Thank you very much. Yeah, I have. That one works perfectly. Okay. Oh God, keep pressing the wrong buttons. Right, so everybody knows what they're doing. Let me reiterate what I want you to do. I want you to try these questions, and you can go back over our shared notes, and especially the bottom, which is question E, which is kind of how to do question E. Okay, so question 2 on the previous page is how to do part E. So have a go at those, and then I'll come back to you. And so I'm going to put a timer on my phone, and I'm going to switch my microphone off, but the speaker will be on, so I'll be able to hear you if there's any swearing or such like. But okay, so I'm just going to switch my microphone off and go off for 10 minutes, and then I'll be back in 10 minutes or less than 10 minutes probably. welcome back. Or it should be welcome back to me because you've already been here. Right, hello everybody. Right. Hey, can you all hear me? Hope it's turned back on again. Ooh. Somebody's already put E in there for me. Thank you. Thanks. Ninesh and Lawrence, well, thank you for that. Right. Okay, so let's go through the components. Oh, I have some more messages. And so I'm going to put, okay, right, brilliant. So you can hear me. Right, on the shared notes, okay, I'm going to put some of the answers then. Right, so if I put, right, so this is not pound sign, so 3A. And let's go. So how many components are there in this mixture? So what I'm having to do is go back over and look at my Word documents. I'm doing that at the same time. So this has 4 components, which you can see. So 4 peaks equals 4 components. Okay, so you put one mixture in, it gave you 4 peaks. That tells you got 4 components. And then, what quantity could be used to identify each component? And that would be the retention time. If anybody didn't get that from the first one. So the retention time and we used ID. So it can be used to identify things. Okay, so you have to use same solid phase and yeah, the same solid phase and the same inert gas to be pushed through at similar pressures, and it has to be done at the same temperature to get the same retention time. So retention time can be used as long as same. So according to your reference, whatever your reference says for the, as long as same solid and well phase is used. as well as and you'd want to, and obviously same solid phase, same stationary phase, not solid phase. What am I saying? So you're using the same stationary phase, mobile phase, and temperature, because remember it's always done in an oven. You want to use the same temperature. Okay, so that would be B. Okay, and then why is this identification not totally reliable? Would anybody like to share their thoughts? The public chat on why this identification may not be totally reliable. Nobody's got any ideas, or you've all fallen asleep?
Because components could have the same retention time.
Good, because some components can have the same retention time. Okay, good. So that if you could, do you know how to put it into the shared notes, Justin? Okay. So let's see. And we put. Oh, I'll have to type it. I'm always so slow. Thank you, Justin. So some components may have the same. Yeah. reaction time. Oops, if I can spell time properly. Okay, good. And what technique could be used to confirm the identity of each component? Does anybody want to write that into the public chat or give me any? Put your mic on and tell me. Mass spec, yeah, definitely. Good. Mass spec. And if we put that into shared notes, oh, there we are. Mass. Okay, and then E, some lovely person has put the answers on already. So if we look at E, use the gas chromatogram to calculate the percentage composition of the mixture. And thank you, Ninesh and Lawrence. You can put that there if you want, by Ninesh and Lawrence. We can see that what you have to do, it's given to you in the brackets on the side of each one. So the composition's already given to you. So you add them together and divide it by the total. So we make the total first, which they've done here. So if I'm just going to add label to that, and that would be, oh, I should write sum of compositions, sum of, let me use the proper technical term, peak area. Yep, there we are. Sum of peak area in spectra. Okay, so that's what's given above there. So anybody want to correct it? Is it correct? Anybody? Can you please check? Because I haven't. Right. Okay. And then if we have a look at W, having to go through, W is 200. So 200 divided by the total. And you can see 200 divided by 525 times 100 gives you 31.1. And if I just add, we're doing all of them to 1%. If we just put percent in there so that we can remind ourselves that it is a percentage. All of them are percentages. Right, excellent. So I think I ought to double check all of them, and I'm just going to do that really quickly. You might want to check, because I'm always wanting to prove these two wrong. So 200 divided by 525. Yeah, that is 38.1. 100 divided by 55. Yeah, that's 19%. And Z is 75 divided by 525. And that 14.3. And then the last one would be 50 divided by 525. Yeah, 28.6. Excellent. Okay, and then that would give you, so if we had 100 grams, 38.1 grams would be W, 19 grams would be X, 14.3 grams would be Z, and Y would be 28.6 grams. Okay, and then there is an exercise for you to do. And this is actually a true life example. So this is from one of the original Salter's A-level chemistry. And Salter's A-level chemistry, which we used to do at the college here, it actually used real life examples in the teaching of chemistry. So this is a real life example. Okay, and I'm going to enlarge it slightly because I can't read it on that tiny screen. Right, and so here, this technique is used to adapt it illustrates how gas liquid chromatography can use can be used to identify alcohol in blood. Okay, and there we go. So if we have a look, right, so I'm just going to go through it with you. Let me zoom out again. Right, so let's start from the beginning. So determination using gas liquid chromatography. Okay, and if we have a look here, right, a sample which is a mixture of several similar compounds will produce a trace showing a sequence of peaks for each compound. In general, for compounds of the same type, more volatile compounds have shorter retention times. So more volatile, lighter things that become gases more easily. Okay, and then here we are, put it through. Okay, and the following information to investigate how to use. Right, the chromatogram, is what the technical term is, illustrated in figure 1, was produced by a mixture of the first 5 straight chain primary alcohols. So if you can find the retention times. So that would be your task. You'd find the retention times and then estimate the retention time for the hexane 1-ol. So if we have a look at them, they are methanol, ethanol, propan 1-ol, etc., etc. Sorry, I'm getting some emails as we speak. And then the blood is analysed for alcohol content. An exact measured sample in is diluted with water and a standard made. So we know how to make standard solutions. We've done that in class. Standard amount of propan 1-ol is added. A measured sample of this mixture is then analysed. The gas chromatogram contains 2 peaks corresponding to ethanol and propanol. The area of each peak is proportional to the amount of compound in the sample. Okay. But the instrument sensitivity may vary from run to run. Using propan 1-ol to overcome the error, the detector will give a high reading for all propan 1-ol peaks if its sensitivity is high, or a low reading for all its peaks. Okay, either case, the ratio of ethanol and propanol will always be the same. So as long as the conditions are the same, the ratios are the same. Okay, in fairness, at least 2 determinations are made to make sure you get a good average. Commercial instruments calculate peak area electronically. However, it is possible to regard a peak as a triangle and calculate how we've been doing. Okay, so that's what we've been doing. So if we have a look, and we have a look carefully, oops, like we can see 1, 2, 3, 4, 5 of these samples of alcohol. Okay, and we can get the retention times. And then figure 2 is the different traces. And you'd use what we've done before, what we've done on the previous pages, to calculate the area under the peak. Now, this is quite tricky, and I think it will take you some time. So this is your next set task. And obviously it gives you a good 20 minutes to the end of this lesson. If you have any questions, can you put them in the public chat? What I'd like you to go through is read through the whole thing carefully and see if you can calculate the area under the peaks. If you could please send me even just a photograph on your phone of you having tried some of it, then I can at least see. Ooh. This is a really good question, Holly, because I also only have an electronic copy. So if we put it at 100%, I'm pretty sure you could measure it under your screen. Have it go. And that's a really good idea. So somebody could put the measurements on. You can share them amongst yourselves. Really, to be honest, if you say I estimated it was this, and this is the answer I got, what I'm really interested in is, have you got the method right? Okay, so Holly, so even if you just estimate for me and do it from estimations, I'll check. If you send them to me, I'll check them, because what I'm interested in is, have you got the method correct, the actual correct answer is lovely, especially if I'm going to be in the same situation as you, Holly, that I'm going to be doing electronically as well, because my hard copy is locked into the lab, as is my A-level hard copies with all my answers and everything in them. So I'm having to go through everything again at home. So it's not an easy task, but I think you all should be able to give it a go, because actually it does come up. Using this method does come up later on. Oh, somebody's typed something in the shared notes. Oh, there we are. So Alfie's you've got someone giving you the just the base and the height, please. So the calculation should be done by the person themselves. Thank you, whoever that is. Be grateful. Okay, and then I'm gonna log off now and leave you to do that, and then we'll come back together on Thursday, not so early this time, so at our usual lesson time at 10:45. So I'm not going to log off or switch it off until whoever it is, thank you very much, whoever you are, putting the weeks in. So if I just put above that, page, your booklet, you know which page it is. And I'll stick that in bold. I'll comment on the public chat. There we are. Thank you very much, whoever's putting the values up. Oh, this is a really good question. Can we access the shared notes? Once they're done, I'll copy them and paste them into a Word document, and I'll put them on the AOL. And so if we look at Unit 15 in the AOL, it should be able to come up. Okay, hold on a second. Right, if I do this, no. How can I share my own screen with you? I think there was a way. I don't remember. Nope. So can you all see my screen? Just double checking. Right, so you can see my screen. Right, and so if I go straight away to the portal. Oh, okay, right, portal. So I'm going to the portal, and so this is my home screen, and I go to the AOL. And it comes up with my dashboard, so you should come up with something similar. And if I go to courses, I've got you somewhere here, and that's you. Right, and then if we look, I'm going to student view, so this is what you'd see. Okay. Oh, there we are. So this is what you would see, and I hope you can see it on our screen. Right, and then I could go to classroom learning, year 2, and it should have unit 15, which is this one. And I'm just going to put it in classroom resources at the moment. Currently, there are just those two, but I'm going to add, obviously, the shared notes in here. So you can find both of those. This is where you can find them. Okay, right, and I'm going to stop sharing now, and I should be able to go back to my conference. Right, okay. So does that make sense to everybody? Nobody's saying anything and nobody's put anything in the message. Okay, good. Right, so so it will be in the shared notes in Unit 15. So if I take all of this, oh, sorry, someone's still typing. Okay, all look out. Right, I'm just going to take it as it is. Okay. You can put your mics on. Okay, and if I go back to the shared chat, right, so I've shown you where to find everything. I've copied the shared notes. Someone added to them while I've been. Okay, I thought, nope. Has anybody added anything? Oh, maybe I need to copy and paste again. I'll double check. But I've copied them onto a Word document. I'm going to put it where I showed you on the AOL so that you can see in Unit 15 where it says Classroom Resources, so you can all access it from there. It also saves us from emailing large copies to each other. So I can, so I'm putting everything in there from now on, so I don't have to email you individually. If you get stuck, if you want any more guidance, you can email me, let me know. I'm going to log off now and I'm leaving you that. And oh, I just want to remind you, this is for Thursday, so this Thursday, and our next lesson will be at 10:45. Okay, any comments? Any questions, anybody? Give you all a minute just if you've got a question or anything. Yeah, anybody else? Got all these people who have been really quiet, wondering where you've all disappeared to. Fatima, Naomi, not said anything since the beginning. Minesh, Piers, Safi. Okay. Okay, if that's everybody understands what they need to do, they can understand where they can find things, any copies of things, then that's good. And I will speak to you on Thursday. Okay, have a good couple of days, and I'll hopefully speak to you. Won't see you, but I'll speak to you on Thursday. Bye, everyone. Bye-bye.